facial neural network. Myself, Nandra. The contribution of the research is for the methods for identification of gender. Fingerprint image collected by the biometric scanner is presented in this page. So on this biometric scanners you can actually take the images and that images can be put forward. So finally what the image analysis will be happening and the ANN is being used to identify whether it's a male or female. Okay, so which is definitely going to be useful at the importance of uses of it. We have also designed a GUI based system for working out with the all digital image processing part and also the ANN part. So both the part we have designed the GUI using the MATLAB software. Over here, the unique fingerprint, there is something unique in everyone's finger. Like most of us now evidently know that the fingerprint is always unique. Even the twins having the same DNA structure, similar DNA structures, rather to say, also have a fingerprint, different. So that becomes one of the sound domain to take care into. Okay, fine, the fingerprint has to be different. Then the uniqueness of the fingerprint pattern has been used for biometric security. Being used a lot nowadays. Every university, every offices, they use a biometric identification. Mass disaster identification, wherever such a thing has happened, if you take the fingerprint part, even the Aadhaar card nowadays in India is having this fingerprint, so this adds more to it. And crime scenes, so wherever there is in criminal cases and you want to find out the person through the fingerprint and all of this stuff. So first round will happen that you can simply segregate it using the male and female. So your job is half done, such like a binary division. So once you are suspecting a male to be a criminal, then you can have just divided that in the first stage, and this will again later on keep on reducing the time. Let me make you aware of the few things about the fingerprint over here. There is a unique features of the fingerprint. One is ridges and the valleys. Ridges and valleys in the fingerprints. If you see your own fingerprint, you will find the ridges and valleys. There you can see two lines, lines coming around. So one is known as ridges and second is known as valleys. All of us, we have either of this type of fingerprint, which you can again check it by yourself. One is loop. That means the loop comes in like this over here. Second is whorls. It comes in this way. And the third one is arcs. So it forms the arc shape in this way. So all of us may have something or the other different in our own fingerprints over here. Okay. There is nothing special about that. This is the only thing that there are three types of the fingerprint part over here. The characteristic difference is this. Now this we need to know more properly now. The first one is the loops in female are more. In male it is less. Both male and female having the loops in their fingerprint, but the female fingerprint loops will be more. And in male, the same fingerprint will have a less loops. Second is whorls. Again, whorls. This is fact. This is fact. Whorls is less in female, and male there are more. I'm not saying in females in sense. If you take a female fingerprint, the whorls will be less comparatively to the male.
Particular one thing. Particular
individuals.
No, I am saying that particular finger will be the constant. Which fingers basically?
No.
For a thumb.
For every.
Majorly it is for a thumb. Our study works on thumb, but in general it is common.
Because the UI taking the 5 fingerprints.
Yeah. But in general it is. But this is in general, not specific. For my images which I have taken is of thumb, but it is in general with all the fingers.
So you are saying the number of whorls per finger is less, or the
number of whorls per finger is less.
Okay.
That's what I'm saying. And ridges and thickness, thanks to that, because I was trying to explain that only the number of whorls per finger is less. Ridges and thickness of valleys again in female is more and male is less. This was important to understand because now later on when it comes to the part
cannot be cut.
Yeah. Now the objective is to develop a method that could extract the features from the fingerprint, like image processing part will take care of this and the frequency of the analysis domain. Then examine whether the various classification of neural networks. So we have used multiple neural networks. We came to a conclusion which one is best for these kind of identification. The fingerprint images were sourced, which was available through online. But now if you go and find out, they are not, because so many downloads have happened. Now they have started charging for it. So luckily when we did it, it was free for us. Data set also what was having 200 images over there for 100 male and 100 female. The proposed system, the flow graph goes in this way. First we go ahead with the image processing part, pre-processing part, which is always required to remove the noise and all this stuff. The second is image processing, the actual image processing by which we are going to extract all the required, features and characteristics. These features and characteristics converted into CSV file, given to the backpropagation neural network, and then the identification of male and female is taken place. Pre-processing, the first one is RGB to gray, because all the fingerprints which has been collected was from RGB domain, converting it to the gray. Then background enhancement, and then gray to binary again using the Ostro thresholding network. That's the best one because it goes away with the global identification, covariance it calculates, and then finally it gives you the best the threshold values which can be used. So the maximum threshold which can be taken for the given image, and it works very globally for individual images. So it keeps on changing its value. So there's no certain threshold value you can say in Ostro. If this value is there, it works for all. It always calculates for the individual images because obviously there is a difference between each and every part. Then comes the image processing part. What we have done is to speed up the process, also the processing part of the image processing. Spatial domain, as everyone must be or may be aware of it, the spatial domain works pixel by pixel, and frequency domain is going to work all over the high and low frequencies. What we have done, we have converted into discrete wavelet transforms. Now once you convert into discrete wavelet transform, you will be having the subbands and bands over there. Then DWT was used for the fingerprint images. With DWT, 6 levels of decomposition is done and 19 subbands were obtained. Now the low bands were having the proper energy levels which was useful for us. So there are different types. Low is there, low, high, low. So there are different types of bands. So what we used was low bands were more useful for us. But the energy at the here we calculate, once we go to the frequency domain, we start calculating energies. So the energy of each subband is calculated over here. If you see this A and B, so this is your pixel value, individual pixel values which has been taken. A is the width and B is the height. So the whole image is taken into picture, and then that is how the whole part is converted into the frequency domain. Once it is converted into frequency domain, the images are stored in CSV format. So all the energy values which has been collected is stored in the energy value, converted into CSV. As soon as the CSV comes into picture, it is evident now that we are going to use the ANN part. For the ANN, we have used Levenberg Marquardt 1. Now this is a non-linear. Definitely the data which we have collected is not linear at all. So to support, we need to have a ANN ka non-linear part of functions which was required. So the non-linear function where we have tried with SVM, we have tried with RBF, okay, but both of them could not give a proper result over here. But the result was not promising. Then we came up with this part, because here what happens over it has a damped least squares. The learning part was very important over here because the error was growing more. We had to remove the error or reduce the error. Gauss-Newton was tried, but Gauss-Newton giving a better result was there. While working with Gauss-Newton, we came across with this method or this one also, which works interpolatively with the Gauss-Newton and also with the gradient descent. So both are the best in their world, and then it uses both of them together, and then the error was reduced a lot. As the error is reduced, the learning process was much better, and then the results can be more enhanced. So that's all done with LMA algorithm. A simple GUI based part was done. So if you say stepwise, first job was to load an image in the application, then load the fingerprint of the image. This is converted into different bands. You won't be able to see here very clearly because the image is just being taken up. The lower bands you won't see much images. The data is there, but you won't see any evidently as an image. Once you convert into frequency domains, you have only the various frequencies. You no more see the images over there. When you come to this level of band, it is going to be not evidently see through eyes, but the data exists. Now you can see over here after DWT how the data has been divided. And then the final detection comes into picture whether it is a male or female. Now here the system tested 100 fingerprint images. The system is correctly identified 39 out of 50 images and then 41 out of 50 for male. So overall performance came up to be 80%. So in averaging the performance was of 80%. Now I'll tell you this percentage could increase more if more data could be collected. We tried a lot from the Indian sources to get the fingerprint one, but could not get properly from the direct source. Now the process is going on. We are working with manually taking the fingerprints of as many males and females we can, because that is the rest part. So till now we have collected around 500 plus images, and our target is to go above 800 or 1000 around, so that the accuracy could be more and more improved. Because ANN demands you to have more and more data, which may come up with the better one. So this is the results which we have produced. So here we have a biometric scanner, as I told you, first GUI interface which we have developed. set of features from DWD which is were very useful to us, and then method was found to provide a result of 80%. Here, male and female, yes, very nicely we can identify that. The method can be used for forensic part and the criminal suspects and many other places where we want to uniquely identify.
Okay, thank you, Mahendra. Is there any questions from the audience?